All right, so orthographic projections, orthographic projections. So I'm going to open the chat box. So what does ortho mean? Any ideas? Straight? Ah, close, but no cigar. Ortho. Orthogonal, right? It's short for orthogonal. That's very good. So what's orthogonal mean? Perpendicular. Good. Right angle. Right. Correct. So ortho means right angles or perpendicular. Graphic. And can you tell me what graphic means? Graphic. Picture. Okay, so, or view or something like that. So orthographic means you're going to look at an object at right angles. So you're going to look at views that are at right angles to each other. So that's what orthographic means. Okay. Here's an orthographic projection. So on the left side is like a three-dimensional representation of a widget. This might be similar to something you're drawing in SolidWorks. Okay. And so orthographic is a 2D representation of a 3D object. So sometimes you need more than one side, right, to get an idea of what this thing looks like. So you're going to have homework that creates these orthographic projections from a 3D representation. And then you'll have homework that takes the 2D orthographic projections and you have to draw the 3D representation. So you'll learn to go both ways. Now in SolidWorks, you typically draw in 3D and then you create the 2D drawings from that. Okay, so your brain will be pretty good by the end of the semester flip-flopping back and forth between 2D and 3D. And that's part of the reason we do have you do it by hand as well as on the computer. It'll help you be a better engineer. Okay, so typically we have a top, a front, and a right side. Most drawings, you only need those three views to be able to fully show the object. Now, some objects are weird shapes and stuff, so you have alternate views and things like that, and that's at a higher level. For this class, we're going to be using mostly top, front, and side views. Okay. So here's a great graphic showing the 6 principal views. Okay, so you don't only have top, front, and side. Sometimes that's all you need to successfully represent an object. But you also have the left, the rear, and the bottom views. Okay, and the difference between third and first projections are which views are the ones that you're going to dominate on. And we have some videos showing you how that works so you can get a better idea. So a common thing we do is do the glass box method. So that's where you envision a glass box around the object that you're sketching. Okay, so each side of the box is one side of the view. It's orthographic, it's orthogonal. Those sides of the glass box are at right angles to the projections from the specific side. So this is what we mean. So you've got this glass box around an object, okay, and then you project out. You project from this top view up into the top of the glass box, and then you project from the bottom down to the bottom of the glass box, and then the front, the sides, and the rear. Okay, so you can see that, you know, in this case, side B is sloped, so it's pretty long, right? Physically, it's a long dimension, but when you look at it from the top, it's rather short, right? Because you're looking at it orthogonally. Okay, and then you see the projectors from the different parts of the object. Those projectors are right angles to the object itself. So it goes at right angles, It intersects the sides of the glass box at right angles, and then you can draw that view based on those projectors. So that's visually and mentally how you have to kind of get used to looking at it. And then when you unfold the glass box, you get the different views. So, you know, on the left side here, you've got the front view. Okay, this is the right side view. This one way over here would be the back, right? The way it's unfolded. And then you have the left view on the left side. And then the top view is the top of the box. And you can refer to the right side image, right, when it's halfway unfolded to kind of see how that works. Okay, so for some of you, this is really obvious. And for some of you, it's really hard to see. Okay, so some people have a really tough time visualizing this. So the more you practice, the better it'll be. What are the dashed lines? Very good question. The dashed lines are hidden lines. Thank you, Benjamin, for responding to that. So they're the hidden lines. They're the lines that are there, but you can't see them from that side. Okay, so we'll talk about hidden lines and how to draw them properly and all that in upcoming things. Okay, so here's an Ortho Animation, an MP4 file. This is a glass box visualization, so I'm going to go ahead and stop sharing and then go to YouTube, and hopefully everything will work. Well, you can see this is a common technique used. People will color their 3D representation for the different sides that they're going to project out. Okay, so you can kind of see how these side views are built up based on the three-dimensional representation. Okay, so you'll get good at doing this, and we'll have some techniques. And the ILM, you know, the author's really good at doing example drawings. So I encourage you to look at the ILM for this chapter and watch her sketch some of these things. So we have principal views. So this is an example out of the book. Okay, so we've got some principal views here, and we've labeled the front view. Okay, so the one in the red box, okay, this one right here, which view do you think that is? What do you think that's called? Okay, we got some answers. Top, 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 top. Good job. That is the top view. Okay, so let's go to the next slide. Okay, the one with the red box around it now. What is that? Right. Okay, that's the right side view. Good. What about that one? That got a few people in the quiz. I think that was back or rear, right? Depends if you're British or American, right? If you say back or rear view. So we call it rear. And that one, left, very good. And of course, the last one is the bottom view. You don't have any choices left. Okay, so that's pretty straightforward. So if you look at the right side view and the left side view, what's the difference between it? I mean, can you put in words? The lines are different in what way? Hidden lines. So you got different hidden lines, right? Because you're going to see different structures from different sides. Okay, and then maybe also they're mirror images of each other too, right? Because of the way they're unfolded. Good. So mirror images and different line types. So we have visible lines and hidden lines. So we're introducing you to line types pretty soon. And top and bottom, same kind of thing, right? You've got hidden lines and visible lines, and they're mirror images too. Okay. So the little box in the corner there, the glass box I put back in, is, for those of you who don't see it right away, if you're looking from the bottom up, okay, you're gonna just see this U-shaped thing, right? And the dotted lines indicate that there's some hidden structures you can't see from the bottom, like this part here. I hope you can see the cursor. So this part here, maybe I can draw on this thing. Let's see. Let's do pen. So this one, you can't see from the bottom. That's why it's a dotted line. Okay. And then this guy here is this one. So you can't see it from the bottom, but it's there. So it's a hidden line. So that's this one. So when you do your drawings for your homework, you don't want to leave out hidden lines and things like that, because we'll dock you for that, right? So that's why we practice it a lot. Okay. Let's see. Okay, I'm going to use an arrow to go back. Okay, which views have the least amount of hidden or dashed lines? Well, the top view doesn't have any, the front view doesn't have any. Okay, and usually you make the front view the most complicated view, so you have the least number of hidden lines. That's kind of a rule of thumb. Okay, standard views. When constructing an orthographic projection, okay, you want to include enough views to completely describe it. So sometimes you only need one view. Think about where that would be the case. Most of the time you need at least 2 views. And then we often will draw 3 views as a standard, okay? So the more complex a part is, the more views you'll probably need. Simple parts, not so much. Okay. What are the standard views? Front, top, and right side. Those are the 3 standards we typically draw in the US, okay? The other views don't typically add a lot of information. Sometimes you have to include another view. If you have some weird sloped feature, you might want to include that as well. Okay. All right, so let's see what you guys can come up with here. This is a 3D representation basically of a rectangular solid, like a shoebox. Okay, so how many views do you need to draw to completely define what this box or block looks like? Some are saying 3, some people are saying 2, 3, so it's a mishmash. So somebody said 1. Okay. So let's see. You need 2, right? Because if you have this view here and say, whoops, I'm having a hard time drawing with this mouse, right? This one. Right, that's the front view, for example. So you know the height and you know the width of this thing, but you won't know the depth. So you need another view. So you can either do this view here, right? And then you'll know how deep it is. So those 2 views would be adequate. Or you can do the top view instead. You know, this one and the front view. Right? The top view will also give you this dimension, so you'll know how wide it is or how deep it is. Okay? So you only need two views to fully and completely describe this block. Okay. Here's a good one. This is a sphere, in case you can't recognize it. Okay. So a sphere, how many views do you really need to draw? Now you guys are getting it. You only need 1. Very good. Okay. So 1 view, for a sphere. And it only has one dimension. So you only have to tell everybody what one dimension is. And that's the diameter or the radius. You can use either one to define it. Okay. Somebody asked, what about the figure on the test? I'm trying to remember. Oh, that had a hole in it, right? Yeah, that was a rectangle like the previous one, but it had a hole on top. Is that correct? So all you need are two views for that as well. Because the front view, you would put the hidden lines for the hole. So now you know how deep it goes. And then the top view defines where the hole is. Okay, so the top view will define where the hole is placed and also how deep it is, how far back it goes. And then the front view shows you those dimensions from the front side. And then you would have hidden lines showing you where the hole is in terms of how far down it goes. Okay, so think about it, you know. You can go back and retake the test, right? It's good that you're thinking. That's how you learn, right? So I'm really happy you guys are doing that. So when you decide which is the front view, you want to pick the side that has the most features, okay? And the fewest hidden lines is another way to look at it. So you'll have this 3D representation, and then you'll pick one of the sides and say, oh, that's going to be my front view. And then you draw from there. Now on the exams, we tell you what the front view is. And we do that for our convenience because we want to have an easier time grading it. Right? But on the homework, on some of the homework, you pick the front view. And sometimes there's, you know, two options. You know, you can pick two different sides to be the front view because they're just as rich in complexity. Okay? So the front view shows the most features or characteristics of the object, the least amount of hidden lines, okay? And then you can draw the top and the right side from that view. All right, now this is really important for how you draw stuff, okay? The alignment. So the front view, right? Once you decide what the front view is and you decide how big you're gonna make it, right? The top view will be on top of it, vertically aligned to it. And it has to be vertically aligned. It can't be over here, over here. It's going to be vertically aligned. So the edges of the front view will line up with the edges of the top view. Okay? And then the right side view will be to the right. I don't know if it's going right or left for you guys, but it'll be to the right of the front view. Okay, so it's like an L. So top has got to be on top of the front view and right's got to be to the right of the front view. Okay, so let me go, we'll have some examples. So this is an example. So typically you would draw this as the top view right on top of the front view, and then the right side view is to the right. Okay, the key components, let's see if I can erase this thing. Is there a button for that? I don't want that. Oh no, I just turned captions on. That's weird. Do you guys like that? Or is that annoying? I didn't know I could do that. All right, well, we'll leave it on and see how annoyed you all get. All right, so back to this alignment thing. This is real important. So usually you will draw the front view first, once you decide which view that is. And then you'll draw these projection lines up, or projectors. And in AutoCAD, they used to call these construction lines. Okay, so you just draw them up, and you'll use graph paper, so it'll make it easier. And then you know where the sides of your top view is. So the edges of the top view are lining up with the edges of the front view. And you leave a certain amount of space in between. Okay, and then when you draw your right side view, again, you draw projectors out so you know how high it's going to go and where the base is. Okay, so that defines the top and the bottom of your right side view, and then the left and right of the right side view is determined by how you drew the top. Right? If you made this a little shorter, of course, these wouldn't be as big and whatnot. Okay, and we'll get into some details how to do that as well. Okay, so the basic concept that I'm trying to teach you right now is that the top view is aligned with the bottom view, or with the front view, vertically. And the right side view is aligned with the front view horizontally. Okay? So let me see, I got a few more people are showing up. All right, so that's the idea there about the alignment. So that's real important. Also, when you do this for homework and for the exam, another really important thing is you don't label your views. You don't say front, right, top. We label them in some of our slides so we can talk about the different views when you're learning about the different views. Okay? So if it's real important you don't label your views for homework and you don't label your views on the exam because we take points off for that. It's a standard, so you'll be drawing front, right, and top views for the most part. Okay? All right. Well, I can't draw a straight line on the computer. It's aligned with that one. See how they're aligned? Okay, exactly. If you make this thinner, this top one thinner, let's say you draw it like this instead, then it's wrong. Okay? So here's a nice video talking about the difference between first angle and third angle view. You guys had some trouble, some of you had some trouble with that on the quiz. So third angle is what we use in the US and what you will use. First angle is what they use in, I think, in Europe and Japan, places like that. Now you might have to use first angle in your future job, but we'll be sticking with your drawings, we'll be sticking with third angle for the semester. And then we'll have some multiple choice questions and stuff like you saw in the ILM quiz where it's like, which is first angle, which is third angle views, okay? So you'll get some of that in the quizzes. All right, so let me see if I can do this as well.
Clan McCad. Okay, so today we're going to have a look at first angle and third angle projection in engineering drawing. We're going to look at first angle first, and what I want you to think of is having the actual object you're going to draw on top of the paper itself. All you're going to do is imagine yourself rolling the object in the direction of whatever view you're looking to create. And what you see from the top down is what you draw. Okay, so for third angle, I like to think of it as if you're unfolding a cardboard box into that traditional flat pack pattern, looking at the front view itself as if that's all you've got to start with. What would be on the right hand side of that object would come out to the right, and what would be at the top will come out above it. Now, viewing these side by side, you can understand why some would compare them as direct opposites to one another. I like to think of them, as I've shown you, in two different ways entirely, and I hope that helps you remember it. In my next video, I'm going to use the exact same setting to lay out a small mechanical component in separate views. It has some asymmetric features and holes and things that will help it really get across a realistic example of how to do this. Thanks for watching, and I'll see you next time.
Okay. We'll go ahead and watch the second one.
Hello and welcome to Clan McCad. So today we're going to have another look at third angle and first angle projection using this little guy here. Now this is an X-ray view of the object. Everything in light grey is the solid body, and everything in dark grey are holes travelling through the object perpendicular to our current view. Now on the left hand side you can see a feature that ends with a dome and a hole that travels not all the way to the edge, so that will be concealed from any external viewing. On the right hand side, however, we have a cylinder where a hole does travel all the way out to the edge, which we'll be able to see right through from the external side. At the top there, we have another hole travelling through, which just allows asymmetry in that direction as well. One side will have a hole, the other will not. Okay, so here's a quick look in 3D, just to back up what I've just told you. So once again, let's look at first angle first. Now we're going to use the same front view in each example. The cylinder is going to lie on the right, the dome on the left, and the hole at the top, as far as unique features go. What we've got to remember is to use that 90-degree roll in the direction of whichever view we're trying to create, and whatever you see looking straight down from the top is what you're going to draw. The result of this, as you can see, is that each respective feature on the front view lies on the opposite side on each projected view. So the cylinder on the right, the drawing of that facing you lies on the left, the hole at the top lies on the bottom. Okay, so moving on to third angle. Again, we're going to use that exact same front view, and using that cardboard box thought pattern I explained in the last video, you can quite easily see that what we're going to do is we're going to pull out the nearest side to the view we want to create by 90 degrees until it faces us, and again, just from the top down, looking down, what do we see? That's what we draw. Now what you'll notice from this method is that the features on the front view actually lie in the projected view that's on the same side as it is on the front view. So the cylinder on the right there is in the right hand projected view, and the hole at the top is in the top projected view. Okay, so once again, I'll end this on a comparison so that you can kind of decide for yourself how you would maybe like to remember it and see the difference between the two. So that's probably us for third angle and first angle for at least a while. Let me know what you thought of the videos, and if you have any suggestions as to what direction you'd like me to take on any videos CAD related or drafting in general, let me know. I've got a few ideas in the pipeline. Next thing's probably going to be 3D modelling methodologies. It's not really something that's heavily discussed, and I really want to dig into that properly, so that'll probably be the next thing coming your way.
So that's a really good video as well to watch. And if you don't quite get it, just watch it several times and maybe find some other videos that can help you visualize it. Get something and, with some structure to it, and flip it on the piece of paper like he did until you get it to where you understand it. Okay. So let's see. Yeah, so we've got first angle and third angle. So the way I remember is third angle is the American way. It's our standard way of doing it. I think for most of us, we kind of gravitate to that as being natural and normal. I've had some students from other countries in Design 1, and they're more familiar with first angle view, and they find third angle weird. Okay, so just an FYI, and if you're ambidextrous, if you can look at either one very quickly and see it, that's even better if you practice it enough. Okay, so what do we use in this class in the United States? It's the third angle. Okay, and here's another way of looking at it. You can see there's a symbol you use in your CAD drawings, in your engineering drawings, that show the symbol. And the one on the left is a first angle projection, and the one on the right is the third angle projection symbol. And I'd have to think about a mnemonic to try to remember which is which. So I'm trying to see it. Okay. So if you make this the front view, yeah, then this would be the right side view. All right. And then this shows you the difference in two different examples. Okay, so here, this is the front again. But you can see the two front views are the same, but the right side view is different from the top view. Okay. Or what's defined as the top view. The one way to think about it is in the first angle projection, the bottom is drawn on top of the front view. Okay, so you can imagine if it's all hidden lines, and if you're looking at it from the top and you don't see hidden lines, you see actual visual lines, right? Then you're looking at the first angle projection. Okay, you might want to think about it a little bit. Oh, this is a really cool thing I'd like you all to do. Let's see, we got a little bit of time. I'm gonna go click on this and show you a little bit about it. And then you can go through this visualization exam or test to see how good your visualization skills are. And you can improve on these things. You know, it's not something you're born with. You learn these skills. Okay, so let me go ahead and stop sharing and then reshare. So this is that website. The link is in the lecture notes. I have to open up chapter 2 so you can see the lecture notes and the links. So they have questions like this. So there's question 1. Which cube cannot be made based on the unfolded cube? So is it A, B, C, or D? And so I'm going to open the chat box and see what you guys are saying. Everybody says B cannot be made. Okay, and then what about the second one? Again, A, B, C, D. So you guys are saying B. Yeah, because you got 3 darkened circles and you only have 2 here. So anyway, you get the idea, and it gets progressively harder as you go along. And they'll give you a score for fun and all of that kind of thing. All right, so I encourage you to do that. And I'll go back to my PowerPoint. Okay. So go through the entire test and work on your visualization skills. Okay, and then there's another one here, an aptitude test, which is basically matching things and seeing relations and shapes and stuff like that. So, you know, go ahead and go do that, and see where your strengths and weaknesses are. Okay, so this is the bottom line. You can learn this. So they've done exams, entrance exams at some of the engineering schools where they do these kind of tests. And if the students don't do well on them, they actually make them do a short course where they practice just those kind of visualization skills. So if you did art and sketching in high school or middle school or even in grade school, if you've had to sketch things from different views and that kind of thing, you'll probably be better at these exams. If you've never taken the time to sketch things from different angles and views, you might have a harder time visualizing it. So it's good to go through, see how good you are at it, and then come up with ways of learning this. And so some of these exams will have links to help you learn those skills further on your own. Okay. All right, we already did that. Review the first, yeah, okay. So I think I'm gonna stop here and start with line types on Monday. So we did views, so you can read ahead about line types if you want, and then you'll be familiar with it, or take a look at the lecture slides ahead of class, or go through the ILM. Okay. Finish up the homework for chapter 1. You know, look at the questions at the end of the chapter There's a quiz that's posted for chapter 1. It's multiple choice, one fill in the blank question. It's taken right out of the book, so they'll look real familiar if you've read the book and you've gone through, you know, some of the stuff at the end of the chapter, the questions and some of the example drawings and that kind of thing. Okay. Are there any questions? Feel free to put them in the chat box.